So you would help Kendall if you could. All right, Audrey, help Kendall.
When two straight lines intersect the vertical angle.
Okay, what vertical angles are you thinking of, Audrey? Okay, angle N would have to equal angle X because vertical angles are equal. Okay, informal statement 13, that's true.
So that would mean M and Y.
Okay, M and Y are also equal. So we're saying that these two are equal and these two are equal. Kendall, did that help? Is she a good friend? So Kendall, Audrey said that N is equal to X and M is equal to Y. But I don't want N equal to X and M equal to Y. I want M and N equal to each other. And she went and got them equal to X and Y. I mean, she's a bad friend. She confused the situation. Ethan? I think Chris knows back there.
So if y equals m and n equals x, then n equals n.
Why?
Because if x equals y, then if x equals y.
There's an axiom we need to use right now. So let's look through the axioms. Kendall's been on this axiom page, so maybe Kendall's found it. There's actually two axioms you could use.
Quantities that are equal to the same quantity, or
Good, you actually said them both. Kendall said substitution. Well, n equals x, right? So I can take n and right in there for x. Similarly, m equals y, so right in there for y. And when I do that, I've got that n equals m. Hey, that's what I wanted. Or you could say that quantities equal to the same quantity or two equal quantities are equal to each other. So you both actually said the two axioms that we could use there. Good. Was that what you were thinking, Chris? Excellent. Number 7. We have to draw a picture here because they didn't give it to us. So ABC is an isosceles triangle. So AC equals BC. So on your paper, draw an isosceles triangle. So AC and BC are equal. ABC is an isosceles triangle. By definition, at least two sides equal. We're going to say AC and BC are the two equal sides. It says that AC then is extended any distance to D. So AC is an extended, because the line can be extended indefinitely or limited at any point. We're going to extend it to some point out here, D, because I'm about to run out of room on the chalkboard. And it says BD is drawn. Well, 2 points determine a straight line. Through these 2 points, B and D, only one straight line may be drawn, so we're going to draw that one straight line between them, BD. It says show that AD has to be longer than BD. Now look at the picture for a minute. Does AD look longer than BD? They look about the same, don't they? But we're going to show that regardless of what things look like, because we don't trust our eyes, that AD has to be bigger than BD. Now they give you a little hint. They say, why don't you use informal statement 14? So Genesis looks up and says, okay, what does informal statement 14 say? Ooh.
The sum of two sides of a triangle is greater than the third side.
The sum of two sides. What triangle are we talking about here, Genesis? There's 3 different triangles here. The sum of two sides of a triangle is greater than the third side. Which triangle do you want to use? There's 3 in the picture. ABD, the big one? Okay. And so we can say the sum of two sides is greater than the third side. Now look at what we're trying to show. We're trying to show that something's bigger than BD. So if that's the case, we want to show that the sum of two sides is greater than BD. Right? So if we look at the whole triangle, what are the other two sides besides BD? And?
AC.
AC is not in the triangle ABD. You said triangle ABD, right? So AD is one side, AB is the other side, of course BD over here. So we could show that AD plus AB is bigger than BD. That's not the same thing, is it? Rats. Okay, so that must not be the triangle then. Let's find a different triangle, Genesis. ACB. Now here's the problem with that. We want to show something's bigger than BD, and in ACB, BD does not exist. So it must be CBD, and that's okay. This is the way you think through a problem, right? Okay, I want something bigger than BD. Let's look at this triangle then, okay? We want something bigger than BD. We want the sum of two sides of a triangle greater than that third side. What two sides? CB and DC. So the sum of two sides of a triangle, these two right here, is greater than the third side BD. Wait a second. This was an isosceles triangle. That's special, right? Because we know that CB and CA are
It's
equal.
not isosceles.
ABC is not isosceles?
Oh, ABC is but
Right, that's what I'm talking about. This right here is an isosceles triangle that we started with, which is significant because it means we have two equal sides, CB and CA. If CB plus CD is greater than BD, then CA plus CD is greater than BD, correct? A quantity may be substituted for its equal in any process. CA plus CD. CA plus CD. What is CA plus CD? How do you know?
Because you can subtract the C.
Thinking of an axiom or a postulate here. How do I know that AD is CA plus CD?
because they're two given points, only one.
No. How do I know that this whole line AD right here is equal to these two parts, AC and DC, added together?
Is it something to do with the whole greater than the other part?
Greater than? I don't know.
Well, we're looking for AD bigger than BD, aren't we?
Ultimately, yes, but right now I'm interested in this statement right here.
Okay.
If the first of three quantities is greater than the second quantity, and the second is greater than the third, then the first is greater than the third.
How do I show what axiom tells me that
Axiom
this
nine.
line AD must equal AC and CD added together?
If the first of the three quantities is greater than the second quantity, and the second is greater than the third, then the first is greater.
The whole is equal to the sum of all its parts. This is a whole line. These are the two parts. Not greater than any of its parts, equal to the sum of its parts. I'm not showing a greater than right here, Ethan. I'm showing an equal to a sum, right? And if that's true, a quantity may be substituted for its equal in any process. AD is greater than BD, whether it looks like it or not. Let me run through what we did again. We looked at the little side triangle that was formed and we said, well, these two sides added together must be bigger than this because we'd established that the sum of two sides of a triangle is greater than the third side. We then said, well, we said CB, but we could have just as easily said CA. We could just substitute a CA in there, but CA and CD together, that's AD because the whole equals the sum of its parts. So we could substitute an AD in place of CA plus CD, and yep, sure enough, AD is bigger than BD. This is what we call proof. This is what this class is about, is line on line, thinking through how can I get this. And again, it's going to be baby steps. This is just kind of showing you where we're going with this. Okay, so you're not going to have to be able to do this on your own, starting next week or anything. But this is where I'm going to work to get you to be able to see it. Coach you, train you, teach you how to think logically so that you can see these sorts of things. Let's do another one. Number 8. Pictures in your book this time. Go ahead and read what they tell us about this picture here. Kendall, nice and loud.
If BO bisects angle AOC and PO bisects angle COE, show that angle COD is a right angle.
Oh, interesting. Okay, so we've got this straight line here, AOE. We have this angle here, AOC. It's obtuse. I'll Stop at the jokes there. And we've also got this other angle COE. We have bisected AOC, and we've bisected COE. We've got BO bisecting. What does it mean to bisect, class?
Two equal halves.
Divide into 2 equal halves, right? So I'm going to call this angle 1 and angle 2. And we've also bisected angle COE. We'll call this angle 3 and angle 4. So based on what a bisector is, based on the definition of a bisector, we know that angle 1 and angle 2 are equal halves of angle AOC. Correct? Similarly,
Where's D? 4 and so 4 and 3 are equal halves of AOC.
EOC. There we go. All right, good. 3 and 4 are equal halves of angle COE. Now, what they're interested in is us showing that BOD is a right angle. Does it look like a right angle?
It looks like it.
Does kind of look like it, but does that mean it is? No, we don't trust our eyes. But we want to show that BOD is a right angle. Well, what is BOD? What does it consist of?
2 adjacent angles.
Which are?
DOC and COB.
Let's use numbers, they're easier, I'm lazy.
Angles 3 and 2.
Angle 3 and 2, right? Angle BOD is equal to angle 2 plus angle 3. How do we know that? It's horrible D. How do we know BOD equals angle 2 plus angle 3?
Because the line can be divided into 2 equal parts by only 1 point.
How about the whole is equal to the sum of its parts? Right? This whole angle equals the sum of its parts. For that matter, while we're on the topic, what about angle AOE? What's it equal to? It is equal to a straight angle, that's true. If indeed it's a straight line, and technically they should have stated that. I stated as we drew it. AOE is a straight line, therefore, or EA is a straight line, therefore angle AOE is a straight angle. But what is angle AOE equal to? What does it consist of?
All of them.
So,
4, 3, 2, 1.
all
Parts, all of its parts.
of its
Sum
parts
is equal to all any single
added together, right? Okay, so angle 1 plus angle 2 plus angle 3 plus angle 4, correct? Now, since AOE equals 1 plus 2 plus 3 plus 4, and AOE is a straight angle, what does that mean about 1 plus 2 plus 3 plus 4?
It equals AOB.
Well, we already said that.
Yeah, it equals a straight angle.
It equals a straight angle. Now, we could have said this a little bit quicker. We didn't have to necessarily go through all of this because we'd already proven that the sum, added all together, of all the angles about a point on one side of a straight line
through the point is a straight angle.
equals a straight angle, right? That was informal statement number 10, I believe.
Yeah.
The sum of all the angles about a point on one side of a straight line equals a straight angle. That all adds up to a straight angle. Now we know this, 1 and 2 are equal. 3 and 4
Are equal.
are equal. So I could, if I wanted to, since I really only am concerned ultimately with BOD, which is 2 and 3, I could substitute 2 for 1, because 1 and 2 are equal. I could say that angle 2 plus angle 2. And I could substitute 3 for 4, plus angle 3 plus angle 3 equals a straight angle. Correct?
Mm-hmm.
Well, now I've got angle 2 and angle 2. Well, algebraically, that's 2 angle 2's, and that's 2 angle 3's. So 2 angle 2 plus 2 times angle 3 equals a straight angle, correct? We can do a little factoring here and say that 2 times angle 2 plus angle 3 equals a straight angle, right? Just factor out the 2 that's in each term, correct? Just like if we had 2a plus 2b, That's 2 quantity A plus B. And then, for that matter, we could divide by a 2. But what you do to one side, you have to do to the other. Why? Because if equals are divided by equals, their quotients are equal. Or you could say halves, right? Because dividing by 2 is also taking half. Halves of equals are equal. So we know that angle 2 plus angle 3 is equal to half of a straight angle, or a straight angle divided by 2. What is half a straight angle?
A right angle.
A right angle. A right angle is half a straight angle. So therefore angle 2 plus angle 3 is a right angle. What is angle 2 plus angle 3?
BOD.
BOD. So we can substitute BOD for its equal quantity here and say that angle BOD is or equals a right angle. That's proof. That's proving something. We know this, we know this, we know this, therefore this must be true, therefore this must be true, therefore by substitution this must be true, and so this must be true, and this must be true, and this must be true, and then this must be true. It's not, yeah, it does kind of look like a right angle. Yeah, it's a right angle. No, it has to be a right angle. Because this. That's proof. Let's do one more. We got time for one more. Number 9. Kind of a fun one. Show a diameter is longer than any other chord. Interesting. Show that a diameter in a circle is longer than any other chord.
Easy.
Oh, yeah, okay.
All right, so we've got a circle, right? And we've got a diameter. And we've got another chord, and it's really, really long. Now, the diameter we'll call AB, call the center of the circle O, and we'll call this CD. We want to prove that AB is bigger than CD. Or for that matter, any other diameter, or any other chord we could draw that's not a diameter. How can we prove AB is bigger than CD?
Easy. Because a straight line is the shortest line that can be drawn between 2 points. Also, from the middle, which is the center of the circle, is O, right? And that's supposed to know that's 0.
That's a no.
Yeah. Straight through would give you the greatest distance.
I think it just says the shortest distance is a straight line.
And there's 2 straight lines on there, right?
There are 2 straight lines on there. Now we know AB is greater than CD.
A circle or part of one may be drawn without any point as the center, or with any point as the center of any given radius.
Yeah, that's just why. Think about what you just said. All that says is you can put your compass anywhere and draw a circle anywhere with any radius. There's a suggestion here. It says form a triangle containing the chord and 2 radii. So let's go ahead and do that. We know that between 2 points, one and only one straight line can be drawn. So from O to C, there's only one line you can draw. That'll be a radius, won't it? And same with OD. That's a radius as well. What do we know about all radii in a circle?
3, 1.
They're all equal, right? So OC, OD, they're equal, but also, what other radii do I have?
AB.
AB's diameter.
OA
and OB, all those radii are equal, correct? So all these little lines, all equal. Now, why do you suppose it would suggest that we form a triangle right here?
3 sides.
Because we know something about a triangle. You might want to read that again, Audrey.
All of their angles added together equal 1.
We're not talking about angles here, we're talking about sides. You have the right one, you just misquoted it, Audrey. Right thought.
Can I say it?
She's finding it. She got it.
The 2 sides of the triangle are greater than
2 sides of a triangle, the sum of 2 sides of a triangle is always greater than the third side. So look at our triangle. What fact must be true? Anyone?
COD is greater than, well,
CO is greater than D.
The sum, there should be an addition here, of 2 sides of a triangle is greater than the third side.
C plus O.
Well, C is a point. I need a side.
CO,
CO, that's one side.
DO,
Plus DO, that's the sum of 2 sides.
equals C.
Not equals. The sum of 2 sides of a triangle is
greater.
greater than the third side.
CD.
CD.
CD, right? Well, all these radii are all equal, aren't they? We can substitute. We can say that OA plus OB then also must be greater than CD, correct? they're equal anyway. So that means these two lines added together must be bigger than CD. What are these two lines added together?
A diameter.
What is OA plus OB? OA
Diameter.
plus OB. What is it?
Two radius.
They are two radii, but added together they make
A diameter.
which one?
AOB.
AB. They make AB, don't they? Ah. AB equals this. Once again, we can substitute. Just plug an AB in there, and sure enough, AB's bigger than CD. Diameter's got to be longer than any other chord. All right, so just some of the basics, some simple little proofs and stuff we can do, just to blow your minds just a little bit. But more than anything, listen to me. This wasn't to make you feel inadequate. There's a reason I'm able to think through these, besides the fact that I'm the teacher and you're not. I know these informal statements like the back of my hand. I know these axioms and postulates like the back of my hand. I know them word for word, basically. I've memorized them. So you know what you need to do this weekend to get ready for next week? You need to memorize your axioms, postulates, and informal statements. That's your main homework, is to study over, memorize pages 38 to 42. Study over pages 38 to 42. You would need to be memorizing these axioms, postulates, and informal statements. Good news, most of them are repeat statements. A lot of them are repeat statements, aren't they? Some of them are new, but you need to work on memorizing them. Also, I want you to read over page 44. It's a little write-up on Euclid. We'll talk a little bit more about him on Monday. And then there are two problems for you to solve. Page 43, numbers 1 and 2. Don't worry, you're not proving anything. You're not ready for it yet. I know that.
43, 1 and 2.
Page 43, numbers 1 and 2. So no proving anything in the homework. It's just normal problems. We're going to get to the proving later. Okay? We're going to work on that again. Don't panic. Unless you decide, I don't really want to memorize. Then you might as well start panicking. But if you're going to memorize, you're going to be fine. Small steps. I'm going to get you here. Okay? So don't sweat over it too badly. All right, you artists, have a wonderful rest of your day.